Your work for this should be shown on your warm-up paper. We're going to write some expressions together. So let's just look at the top slide here. It says each student in the class has an imaginary envelope. Inside that envelope is an unknown number of triangles. Write an expression to show the total number of triangles in each envelope. So we know everybody has an envelope, or we're going to pretend they do. And inside that envelope is an unknown number of triangles. So if I draw a quick envelope, you all have one. If you're pretending, your envelope might have one triangle in it. It might have 2, 3, excuse me, and so on. It could have 4. It could have any number of triangles in it. So we need to write an expression, an algebraic expression. If you forgot what that is, you look up at the board to the right-hand side and you'll see one. We need to write an algebraic expression to show the total number of sides in each envelope. So what do we know about a triangle? We know that one triangle has 3 sides. We don't know how many are in our envelope. So how do we do that? Well, this is an important number. If the envelope had one triangle in it, it would be 3 times 1 would equal 3 sides. If the envelope has 2 triangles in it, it's going to be 3 times 2. It would be 6 sides. If we have 3 triangles in our envelope, it would be 3 times 3 for a total of 9 sides. So as you look at these 3 numeric expressions that I made, oops. Excuse me. If you look at these 3 numeric expressions, what do you notice that changes? And what do you notice that stays the same? So you see that there's a 3 in all of them, and that the number inside the parentheses, the number that we're multiplying by, is changing. So the one that's changing is the variable. So we take our unknown. Remember, we don't know the number of triangles in the envelope. So let's use x. We'll say that x equals the number of triangles. And we're going to plug that in where we were making variable numbers. Variable means changing. And so as those numbers are changing, we could plug an x in there. So if we did, all of these would become 3x. And that's going to be our algebraic expression, 3x. 3 is the sides of the triangle. We all know that a triangle has 3 sides. And x in this expression represents the number of triangles. So if you multiply 3 times the number of triangles, it's going to give you the total sides. So there's our expression. We're going to use that in the next couple of slides. Oh, I forgot to say this. On your notes, call this question, and you didn't have to write the paragraph down, but all this work that you did, call that number 1. We're going to go down to another step, call this one number 2. If there are 28 kids in the class, write an expression to prove the total number of sides for the class in total. So we already had an algebraic expression of 3x. Remember, that's 3 sides per triangle times the number of triangles, right? So this expression is going to give us the number of sides in how many envelopes? That will give us the number of sides in one envelope. So if there's 28 kids in the class, that means there's 28 envelopes. And every kid has the same envelope. So how could we rewrite this expression so that it would prove the sides for 28 envelopes instead of 1. Well, 28 envelopes is 28 times as much. So we're going to take this expression, and we're going to use a skill we learned yesterday. Here's our expression, and we want that to be 28 times larger. So how do you do that? You multiply it by 28. And 28 times 3x is going to give us the total number of sides for the entire class. So this is an algebraic expression. Let's go ahead and let's make it numeric. Let's plug in the numbers that we know, and we'll actually figure out if everybody had the same envelope. And we knew the number of triangles, we could figure out the total sides in the class. So let's draw an envelope, and let's pick a number of triangles. Let's say everybody in the class has an envelope with 4 triangles in it. Okay. Remember that X stands for the number of triangles. If we go back up and you look right here, X stands for the number of triangles. So if we look at our expression that we have created, if there's 28 people in the class and 3 sides per triangle, and there are 4 triangles per envelope, now we can plug in that number. 28 times 3 times 4. And this is all multiplication now that we have a numeric expression. You can multiply it in any order you would like. So we could use a calculator. Let's do 3 times 4 first because that's easy. And then 28 times 12 is going to give us our answer. Pull up a calculator. 28 times 12. 336. So if everybody in the class had the same envelope with 4 triangles in it, that would be 336 total sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're not going to count all the way to 336, but that would be the answer. If all the kids on the dream team had the same envelope, write an expression to prove the number of sides for all 162 kids on the dream team. So again, we would start with our algebraic expression of 3 sides per triangle times an unknown number of triangles. And then we would have to multiply that by 162 kids on the dream team. So let's pretend they all had that same envelope that we talked about in the last question. This is number 3, by the way. If everybody has an envelope with 4 triangles in it, then we'll be able to rewrite 162 kids on the dream team times 3 sides per triangle times 4 triangles in each envelope. Now we have a numeric expression. 12 times 162 will give us the total sides. (1,944 sides if every kid on the dream team had that same envelope. Okay, so that's the basics of writing an expression from a story problem. It's your turn. You're going to try this one, and then we will check through it together. Humans have 2 legs and dogs have 4 legs. Write an expression to show the total number of legs for both dogs and humans, and then prove how many legs 5 humans and 7 dogs would have together. So this is a 2-part question. You're not going to see it solved out on the video, but this is what you need to do. First, you need to write an algebraic expression. So it should have a variable, at least one, should have at least one number, and it should have a math operation. After you write that algebraic expression, the second thing you're going to do is you can plug in the numbers that you know, and you can create a numeric expression. and solve. So you have some information to get started. I want you to try it, and then when everyone's finished with this slide, we'll go ahead and go over that as a class. If you finish early, there is a classwork assignment sitting over by the light switch. You're going to go over, and it has similar questions to the ones we just worked on. So go ahead and grab one of those and try to get started. And we will check this together in a minute.